Good day, folks. Welcome to Bright's Mind Academy, where we bring brilliance to every lesson. Now, in today's video, we're going to be looking at grade 11 mathematics question paper. This is June paper 2, 2024. Okay, yes. Okay, so yeah, let's just dive into it. Okay, yes. So now, in question 1, remember we have what is this analytical geometry from grade 10, right? The revision. Then in question 2, it is the one that we introduced to you in grade 11. Then question 3, trigonometry. Continuing to question 4. Then question 5, now we start interesting stuff. Okay, yes. So without wasting any further time, let's just dive into it. So question 1 says to us, PRS now. PRS is a quadrilateral with vertices, those ones, okay? We are not told what kind of quadrilateral is this, but by inspection, when you look at it, you can say it is either it is a square or a rhombus, okay? A square or a rhombus, but we'll see as now time goes on. Then P is on the x-axis, okay? Where is P? P here it is on the x-axis, and Q is the y is on the y-axis. Okay, here it is. Okay, so every information that we are given there, we have. Okay. All right, now 1.1 says these questions, the first ones are just master them. Determine the length of PS and RS. Where is PS? Length of PS and RS. Okay, so we want the length. Remember how do you want the length? Sorry. The length of PS, you're going to say PS, it is equal to square root of, I'll say XP minus XS so that I can remember when I substitute, minus YP minus YS, okay? You can say Y1, Y2, but for a purpose of not forgetting, I'll use that one. So that when I substitute, I get it easy. X of P, can you see -5 minus X of S, -2. It is -2, which becomes a positive. Then I square that plus, what is Y of P? Y of P it is 0 minus 5, like that, squared. Okay. Then now I get something like square root of -5 plus 3. Sorry, -5 plus 2, it is -3. -3 squared, it is 9. When you are here, just punch your calculator. I do not have it right now. I don't need it for now. Plus 5 squared, which is 25. Then square root of 36. This is 6. Okay? Yes. Sorry. The distance between PS is given as 6 thereof. Okay? Yes. So now let's move on to finding the length of RS. Okay? The length of RS. So you're gonna apply the very same approach also. Okay? Let me see here if I'm correct. No, here. No, it's not 36, it's rather 34. So it is square root of 34. Okay? Yes. So, yes, that's the length of PS. Okay. The length of PS, let me just indicate this here. Okay. Yes. Now let me find the length of what? Of SR. RS or SR, however. You can say, I'm going to say SR. Okay, let me say RS as they want it. Remember the formula, you're not necessarily given a mark for it, okay? You just get a mark for substituting. What is the value of R? The coordinate of R there, I cannot see it. I think it is 3 and -2. Yes, 3 and -2. So I want the X, it is 3 minus the X coordinate of S, it is -2. Can you agree with me? Negative and negative is +2 plus Y here, it is -2 minus, when I subtract -5, you agree with me, it's going to be positive like that, okay? Therefore, I get something like square root of 9. I'm sorry. Square root of 25 plus, what's this? 9. Okay, so similarly, I get the same answer, square root of 34. So now these answers are going to help us where, in terms of identifying what kind of shape is this one. Remember, if now your length and your breadth are equal, it means now this is a what? This is a square. Because this side, if this is equal to, if this side is equal to, if this side is equal to this side, so it means it is equal to that, it's equal to that, yes. Okay. All right. 1.2, calculate the midpoint M, the coordinate of M, the midpoint of PR. Where is PR? PR. So we want the midpoint between PR. Okay. So somewhere there, I'm approximating M, PR. Okay. So how do we find midpoint? Remember, for midpoint, we say it is the x coordinate of what? Of P plus x coordinate of R divided by 2, y coordinate of P plus y coordinate of what? Of R, all divided by 2. So now, let's punch that. We have what? X coordinate of P, it is -5, plus x coordinate of R, it is 3, divided by 2. Then here I have y of P, which is 0, plus y of R, which is -2. I could have said 0 minus 2, still fine. Okay, so I get a midpoint of -1 and -1. Can you see that it is approximately that here, maybe -1, here maybe -1? Can you see that? Yes. Okay, so we have a midpoint there of coordinates -1 and -1. In case you're gonna need them, let me just put them here. Okay, yes. All right, so far you've been doing easy stuffs. Okay, this is just you knowing how to substitute into your equation thereof. Cool. Show that the value of t, okay, we are here. Show that the value of t, it is equal to 3 if it is given that PR and QS bisect. Okay, PR, this line that we have drawn here, and what? And QS bisect. QS bisect. So can you see now they will share midpoint? Can you see that? Yes. Okay. Another thing that you can say, okay, now they are trying to tell you that this is what is a square. Remember, a square, diagonals bisect, right? This diagonal bisect that diagonal. Okay, the properties of a square, you should know your properties very well. Again. So now what you can do, instead of doing any calculations and wasting your time, remember, check, it is 1 mark, right? You can also do this and apply what's this? Midpoint formula to get Q T, right? But I want you to see something. If from here, I want you to check from here, the distance from here to there, it is the same distance from here to where? To there. Are we agreeing on that? Yes. Why? Because remember, you said these sides are equal. Here. So you can use distance formula, but I want you to check the easier method. I say from here to there, it is equal, similarly to there to there. So it means whatever this x coordinate here, if here it is -2, to there, it is how much? It is 3. So I want you to check something. The coordinate of S from the coordinate, okay, to get the coordinate of R, which is X and Y, what did they do to S? Okay, now can you see S moved from -2 to 3? So from -2 to 3, it is how many? How long? How long? What distance there? It is what distance traveled there. Can you see now? You can say 3, this one, 3 minus 2. So it is 5. So it means now they added 5 to the x coordinate of y, okay? Then what happened to the y coordinate of x? X coordinate of y, no, of s, sorry. Then what happened to the coordinate of s here, which is negative 5? Can you see now it moved from y is equal to negative 5 to y is equal to negative 3. So the distance, it is how much? Negative 2 minus 5, which it is 3. So it means the y coordinate moved 3 units. Okay, so this is what they did to get the coordinate of r. Now let's see if it is correct now. The coordinate of s to get r. Oh, okay, let me say these are the coordinate of s, right? But what did they do to them to get r? Okay, yes. So what are the I want you to show something. It's gonna be beneficial for you if you can know this thing. Inspection. The coordinate of x, sorry, s. I don't like to name this one. It is tricky. But yeah. Then what did they do to this x? They added 5. So when they added 5, negative 2 plus 5, it is how much? It is 3. Okay. Negative 5 plus 3, it is how much? Negative 2. Can you see that these coordinates are the same as that one? So this is what I want you to apply and say now if p, it is negative 5 and 0. They also did the same thing. They added 5 to it, then they added 3 to the y. Okay, so to the x here, they added how much? 5. So what was the x original equation? It was negative 5. The y original equation, it was 0. So can you see now the coordinate of sorry, I forgot to label this. This is q. It is what? 0 and what? And 3. Can you see now this is true? Why? Because now the y coordinate here of the x coordinate here, it is 0 because it is the y intercept, right? Oh, already can you see now this is true because can you see it is 0 here? Can you see that? And we already proved that, but we are interested in what? In t. Okay, yes. But the easier method that you could have used, again, this one I want you to take note of it because you're going to use it a lot, especially when you encounter rhombus or a parallelogram. So here what you could have done, you could have said, okay, the x is already sorted. The x, we have negative 2, negative 1, and q, right? Remember, we also have a line that's like that there. Okay, yes. So what you could have done, you could have said, okay, t plus negative 5 divided by 2, it is equal to what? The midpoint, which is negative 1. Then here you have t minus 5, it is equal to negative 2. 2 multiplied by negative 1. Then t, it is equal to negative 2 plus 5. T, it is equal to 3. Okay, yes. Remember here, I'm not trying to make a memo or what. I'm just trying to show you ways on which you can answer your question. Can you see you're required to prove that? So yes. Okay. Now let's move on to 1.4. 1.4 says to us now, determine the gradient of PQ. These questions are so nice, most. Determine the gradient of PQ. If you already know that Q, the coordinates of Q are 0 and 3, how do you get the gradient? Gradient of PQ. You say y coordinate of P minus y coordinate of Q divided by x coordinate of P minus x coordinate of. The reason I like to use these P and Q, it's easy because why? They want PQ. So I say y of the first one minus y of the ganjalo, like that, okay? Then now I locate what is y of P. Instead of saying y2 minus y1 so that you can come here and say this is x1, it's fine. You don't need that. X of P, it is how much? Negative 5 minus x of this is 0. X of P, it is 0 minus x of that one, it is, okay? Then when you substitute that, you get negative 5 divided by negative 5 by 3. Negative 5 divided by 3, sorry. Then the gradient here, it is equal to -5 divided by 3. Can you see this is just 2 marks? How do you get that 2 marks? It is you substituting your points here and getting your mark, your final answer here. Okay? Mm. Okay. Calculate the size of PQR. PQR. Now we are doing grade 11 stuff. Remember, calculate angle when you are doing grade. Yeah, but I think it's grade 10 also. PQR. Where is PQR? I come and say this is PQR. So I want the middle angle. How can I get that? How can I get that angle? I want us to see something. Um, I have to use something that is used in grade 11. So let me see. Okay, now I want you to do this. If you were to cut this into two, like let me draw this like this. I want to show you something. Okay, if you were to cut this into two triangles, can you see that you have cut it exactly in half, such that this becomes your what? Your 90 degrees. You cut it exactly in half because this is a midpoint, okay? Such that such that this becomes your what? Your um, your 90 degrees. Then remember I said all the sides are equal here, and we said one side it is equal to what? The root of 34. Okay. Can I find the length here? Yes. Just tell the examiner that the length, okay, the first thing that you have to tell, the first thing, tell the examiner that the length, sorry, PQ, it is equal to square root of 34. Tell the examiner that. Number two, what you want to find. Remember, I want us to get this angle. So let's name this X. Okay. Remember X, this angle here, I want you to do something. We cut this angle exactly in half. So it means whatever this angle here, PQ, PQR, I want you to take note. P angle QR, it is equal to 2x. Why? Because if this is x, this is also x. We cut it exactly in half, okay? We'll focus on this one half, the first one, okay? Then now how can I do that? Okay, so I can use opposite to that one, okay? Because I can find the length of that one. This is opposite, this is hypotenuse. I can use sine, okay? But now before I can use sine, I need this length, PM. Where's my thing? PM, okay? How can I get PM? You know how to use a distance formula, right? PM, it is, I have -5 plus 1 squared plus 0 plus 1 squared. Okay, you know how to use your formula. Then this is -4 squared, which is 16. 16 plus this is square root of 17. Okay, yes. Now, can you see that 17 multiplied by 2, it is equal to 34? Can you see that this length here, it is half? This length there, this length here, it is half of this length. And this length, sorry, and this length now, since, well, okay, if I have a square, remember I'm already telling you this is a square. This length is equal to that, is equal to that, is equal to that. It is also equal to the what? To the diagonal. It's also equal to the what? To the diagonal. So all the lengths are equal, even their diagonals are equal. So it means this point here will be half, okay? In case you don't know, it's fine. Then after getting this as like that, square root of 17, the third part, it is to apply trigonometry. Remember what does trigonometry say? In this triangle thereof, this is opposite. Remember, you want sine x. Sine x, it is equal to opposite. Opposite, it is PM divided by hypotenuse. Hypotenuse, it is PQ. Okay. Then you say sine of what? Sine of what's this? What's this? No, sine of x, sorry. What is PM? PM is square root of 17 divided by what? By square root of 34. Which this is the same as saying now it is 1 divided by square root of 2. Okay? Then by now, you should have learned that. Remember, I said I do not have a calculator for now. You should have learned your special angles, right? In trigonometry, they are very important. If this is, okay, sorry. If this is, if this is 30 here, remember 30 says opposite divided by hypotenuse, and sine 30 it is half. Again, then this is square root of 3. So there is also another one that says now you have 1, or sorry, 45, square root of 2, 1, 1. But now we want to assign, okay? We have, oh, this one you do not need. You can say x, it is equal to arc sine of, you can put this number as it is, it's fine, and I'll use this one. When you can substitute this number, okay? Yes. Remember, when you are using calculator, you are allowed, it's fine. X, it is equal to what? What is this? Inverse of 1 over 2. How can we get 1 over 2? So we can use this angle and say this is adjacent. And remember sine, sine it is opposite of a hypotenuse. So if this is opposite, it means I'm talking about this angle, and this is adjacent hypotenuse. So it means my angle, it is how much? 45 degrees. Okay, but now remember, therefore, remember what did I say? Take note of. Let me remove all this mess. Remember, I said now to you, remember that PQR, it is what? It is twice X. So you can say angle PQR, it is equal to 90 degrees. And yes, it should be reasonable that it is 90 degrees, because now, remember, in a square, the angles here are equal to what? To 90 degrees. Okay? So this now proves to us now this is a what? This is a this is a what? A square. Okay, yes. So now they say to us the last question, what type of quadrilateral is PQRS? First one I see, I told you it is a square. Why are you saying that? Diagonals bisect each other. You can say equally, okay? Why am I saying they bisect each other equally? Remember, if this is square root of 17, this is also square root of 17. Similarly, this is square root of 17. Can you see now the length is equal? Okay? Another thing that you can say all four sides. Okay? All four sides are equal. You can prove to that. Remember, we proved this one is square root of 34, this one is square root of 34. You can also check this one. If you're not so sure, you can also check this one, okay? All four sides are equal. The third one that you can say interior angle are equal to 90. Okay? Interior angles are all equal to 90. Remember, we just proved that this is 90 degrees. So this is, if this is 90 degrees, this is 90, this is 90, this is 90. Yes. So that was all for question 1. I know I did a long video, but yes, in terms of explaining a concept, you need to. Okay. Now moving forward, now I have in the diagram below A, B, and C of those coordinates are the vertices of triangle ABC. Q is the x-intercept of the line y is equal to AC. Line is equal to AC. Theta here is the angle of inclination of AC, this is the angle of inclination of AC, and now BAC it is given. So every information that we have them, that we are given there in the scenario we have here, okay? Yes. Determine the size of theta. Remember, now theta, it is an angle between the line of inclination and a what? And an x-axis. Okay? This is our x-axis. So remember, you measure an angle starting from the positive or from the horizontal. You measure it going like that. Okay? If your angle was here, can you see that you measure it going there, and the minute you measure it going there, it's wrong. So you should measure it going where? In that direction. Can you see that? Therefore, it means now it's going to be what? This angle here, 180. Can you see that this is 180 here? If I do this, this is 180. So if you want this angle here, the blue one, you're going to say 180 minus the theta, this one, because it is the one that we measure with respect to. Okay? Yes. Okay, let me remove that. So we want that angle, so we know we're going to measure it like that. Okay? So now remember, how do we I calculate my angle. Remember, I'm gonna say the formula says m gradient it is equal to tan theta. Okay? Or tan theta is equal to gradient. However, tan theta it is equal to the gradient. What is theta we are looking for? It what is the gradient for? Did they tell you the gradient of AC? No, they did not. So it's fine. We'll just okay. So now the first thing first, remember this is gradient of AC. So we have to first find the gradient of AC. Which is what? Sorry, not gradient, you do not use this. Gradient of AC, y of C minus y of A, x of C minus x of A. Or they did tell us here. No, they did not. Okay? They just say determine the size. And it is unfair for them to give. Oh, okay, okay, okay. Can you see now we cannot find the length of PAC here? Can you see that? Yes, now that is going to be a problem. So we have to find another way. Okay. Yes. Okay. This is good. That I'm doing this mistake so that you can also see when you're in an exam. Do not become afraid and do what and what and what. This is for 2 marks. Now, what you can see here is that we have this angle. Okay. So is there anything I can try to make? And when you encounter these problems, okay, in grade 11, try to look out for a triangle. Okay. Try to look out for a triangle. Can you see? And this line is exactly perpendicular. Can you see? If I extend this like that, can you see? This, why am I saying this is exactly straight? How am I sure? Can you see now the x does not change? So if the x does not change, it means it is a straight line. Okay. So here, this is 90 degrees. Okay. So remember, if I'm having an exterior angle, if this is y, this is x. If I want z, remember the exterior angle says now z is equal to the opposite. Can you see the opposite angles? Okay. So which are the opposite angles? Y plus z. Can you see that? Yes. So we're gonna say theta. Okay, let me calculate it here. Theta, it is equal to what? 87 degrees plus what? What's this angle here? 90 degrees. Okay. Just tell the examiner that A angle B, C, or Q, A angle BQ, this angle, A angle BQ, okay? It is equal to what? It is equal to, where is it? A angle BQ it is equal to 90 degrees. Okay. Then now theta, we can nicely say it is how much? 127 degrees. Now you have to ask yourself, is it true that this is 127 degrees? Yes. Why? Because can you see that this is an obtuse angle? Remember, if this was a 90 degrees, this line was gonna come like that. This is a 90 degrees. But can you see that it is extended in this portion? Yes. So you can move on like that. Another thing that you could have done, there are so many ways. Remember, this is geometry. You could have drawn a straight line like this. That makes this a 90 degrees at Q, and make it parallel to AB, okay? Such that it is parallel to AB, okay? Such that it is parallel to AB. Now, if this is parallel to AB, we can use these properties. Remember, if this is perpendicular, this is going to be a 90 degrees. Now we can find this angle here. I can name it X and say now, okay, if these two lines, I made them such that they are parallel, okay? And remember, if I have parallel lines, I can have this, okay? So it means X, it is equal to how much? X, it is equal to 87 degrees. That this X, okay? Then, but what I want to what? Theta. So remember, this was 90 and this was X. So it is 90 plus 37. Can you see still the same thing? Yes. Thank you, Hula. All right. Can you see I spend a lot of time explaining only one thing? It is because I want you to understand this concept, but not because I don't know them, I'm just guessing or what. I want you to understand them. Or can you please do me a favor? Do not forget the degrees. Okay, yes. Or I can collect it here and say eta is equal to 127 degrees in case I will remove it by mistake. Now, 2.2, calculate the equation of AC. Now, they wanted the equation of what? Of AC. Remember, for an equation, you need one thing, gradient. Gradient of that line, AC. Number two, you need what? 2 points. Any 2 points. 2 points on that line. Which line are we talking about? AC. So let's execute that. So let's start with the first step. We say the first step, we want to have the gradient of AC. How can you get the gradient of AC? Remember, the gradient of AC, it is equal to tan theta. Why? Because it is this angle here. Can you see that? Tan theta there. Then, another thing that you can do, let me see. Where is it? Oh, gradient of AC is equal to tan. Then you punch 127 there. Then you get how much? Tan 127. Sorry, you get. And can you see now this line here? It is negative. Can you see that this has a negative gradient? Gradient is less than 0. This has a positive gradient. So it means your answer there should be negative. Do not become scared. It is something, I get something like 2 decimal negative 1.33. Okay? But now I'm not done. I just only found step number 1. Number 2 says what? I have 2 points. Yes, I can use this point again. If I have that point, I can say y minus y1. Okay, where this is x1 and x2. Okay, y1, y1, or any point, okay? It is equal to gradient into x minus x1. You can also use this y is equal to mx plus c and substitute m and substitute this point here and get c and then do your final equation. It's fine. But I prefer this one, y minus, the y you leave it unshaken, then minus y1. Which point can I use? This point. Can you see that this point, it is the point of intersection of AC as well as AB? Yes. Minus what is y? It is 4 here. Can you see that 4? Gradient I just got as negative 1.33. This is not a beautiful answer. But yes, x minus, can you see it is negative 2 minus, this is the minus of the formula, then the negative of the 2, like that. So it's going to give us positive. Then when I simplify this, you can simplify this. This is going to be negative 1.33 times x. This by this, it is negative 1.33 multiplied by 2. You get that answer, negative 2.66. Then you take this 4 to the other side, you add it. You get what? Plus 1.4. Okay? Yes. Good. So yeah, this is the equation for 3 marks. Okay? Now, what do I need? Calculate the coordinate of Q, the x-intercept of AC. Now, remember, I now have the equation of AC. Okay? I now have an equation of AC. I can get what? Any point. They say what? Calculate the coordinate of x, the x-intercept. Remember, for the x-intercept, you check the equation. Here's the equation. You do what to that equation? For x-intercept, you let y equal to 0. So here you're going to say 0, it is equal to negative 1.33 plus, or 1.33x plus 1.34. Then I take this 1.34 to the other side to 1.34. It is equal to negative 1.33x. Then I get x as how much? You say negative 1.34 divide by negative 1.33. You'll get a number that is almost perfect, like 1. Okay? You can say 1, comma 0, 1, or just 1. Just 1 is fine, okay? Yes. Then calculate the what? They said the coordinates. Can you see? The coordinates. Coordinates. So remember, how do I write coordinates? I'm going to say on Q, when x is 1, where did I put as y? Okay. When x is 1, I substituted here. Can you see y as 0? Easy and nutty stuffs. Okay. Yes. I'm calm and relaxed on these. I'm not rushing because, yeah, there is no need to rush. I want you to understand how this concept the of works. Okay. Now, determine the integral value of p if points A and Q, A, Q, C. Okay. Determine the integral value p. Okay. Integral value p here. If the points A, Q, C are collinear, what does collinear mean? Let's start there. Let's just start there. Collinear, if things are collinear, it means now their gradients are the same. So it means the gradient of AQ is equal to the gradient of QC. It is equal to the gradient of AC. Okay, it is the same across. So how can you use that to get the value of P? Okay, I can say, okay, I already have the gradient of AC. Do you agree with me? I already have the gradient of AC. I calculated, remember, where is it? When I was calculating the equation of AC, remember that here it is, the gradient of AC. Okay, I removed it. It was here on the left-hand side. It was here. But still, I can see there is the gradient. Can you see now? M, it is that one. Yes. So I know the gradient is AC as negative 1.33. So I can say I can use either this one or this one, however, okay? So I'm going to use QC. QC, it is going to be what? Remember the gradient formula says y of Q minus y of Q minus y of C divided by x of Q minus x of C. I'm writing this formula, I'm reminding you every time. Now, what is y of q, it is y, sorry, y of q, it is 0. Okay, 0 minus, sorry, then y of c, can you see it is negative 4 minus 4, which is the same as plus. Okay, x of q, it is how much? X of q, it is 1. 1 minus p, it is equal to negative 1.33. You can also use the gradient of AQ and the gradient of AC. Remember, you are trying to find the gradient that you're going to want to link this one with the one that you know its gradient. Then this is just a matter of being a mathematician. Do you agree with me? This is just 4 divided by this one. I can multiply this to the other side like that, okay? I can do that. I can say 4, it is equal to negative 1.33, 1 minus p. You can simplify, become a mathematician, but instead I'm going to do this. I'm going to divide by 1.33, negative 1.33, sorry. Then I get on this side 1 minus p. Can you see that this and this cancels off? Then I have what? 4 divided by negative 1.33. 4 divided by negative 1.33. I get something like negative 3.00 something. Okay, negative 3. Yeah, I'll just leave it as negative 3. Okay, negative 3. Then when I take this negative 1, sorry, this positive 1 to the other side becomes negative 4 is equal to negative 3. Then now do you all agree with me when I divide both sides by negative 1, p, it is equal to 4. Can you see that? Yes. I hope you are seeing that. I hope you also understand what we mean by collinear. Okay. I hope you understand what we mean by collinear. Okay. So there is collinear. There is also what we call equidistant. Equidistant. So for equidistance, you are saying the length of AQ is equal to the length of QC is equal to the length of AC. If you are having this physically, so that you understand, this should be a midpoint. And this, let's say, A, B. This is what we mean by equidistant. Okay? If A, M, and B are equidistant, then it means now, let me do this actually. Equidistant, it means now AM, the length of AM is equal to the length of MB. I cannot say it is equal to the length of AB. I will be lying because it is twice. Can you see? But now on the gradient one, actually let me use AQC. Yeah, but either way, I want to believe you're understanding the concept. For the gradient one, the gradient of this one, and the gradient of this one, and the gradient of that one is the same, okay? It only applies to the gradient where you can take, remember it is on the straight line, so your gradient is the same. Yes. Take notes. Okay. I'm moving slowly, but surely. With them, 2.5 says now, determine the equation of the line parallel to BC passing through point A. These equations, I like them. Okay, let me remove this. Maybe I might need this equation, I don't know. Okay, remember this is the equation of AC. So, what do they say to me? They say to me now, determine the equation of a line parallel to BC. Where is BC? BC. Can you see? They say that line is parallel to BC. Let me draw BC nicely. Okay, so that line that I should draw, it should be maybe parallel. Parallel is lines like this. That is parallel. That is also parallel. That is also parallel. But now I should know which parallel do they want me to draw. Can you see? Okay, the parallel line, we understand it is parallel to BC in what manner? And passing through point A. So it should pass through point A. So that parallel lines, we should not only draw just the parallel lines, but it should pass through point A. That is what the examiner is looking for. Can you see now? These two lines thereof are parallel. Okay. This is nice. And if they are parallel, can you see? I can apply the angles what the geometry. Can you see that? I can say these two angles are equal to these and these are equal to 180. Can you see that they're monading? Okay. Let's not get carried away. They want to determine the equation of this line. Okay. Remember, parallel lines have the same gradient. Very important. Parallel lines have the same gradient. So what do I mean? It means now I need to find the gradient here so that I can find the gradient of this line. Okay? Now, I'm going to say, first thing first, calculate the, remember when the equation, remember for an equation you need a gradient and a point, and we already have a point. Okay, a point, it is A. Let me find the gradient of is it B of BC rather, okay? Gradient of BC, here is BC, gradient of BC, okay? So how can I do that? Remember, it is y of b minus y of c divided by x of b minus x of c. I'm going to continue in a straight line. What is y of b? Y of b, it is -1. Can you see there? Minus of the formula. What is y of c? It is negative like this, 4. So it's going to become plus 4. And I'm expecting a negative answer. Why? Because the gradient is negative. Can you see that? Yes. Then y x of b, it is -2 minus what is a x of c, this form. When I calculate that, I get a 3 divided by -6. I think it is -1/2. 3 divided by 3 divided by -6. Yeah, it's -1/2. You can confirm when you calculated them. But now remember number 2. Remember that the gradient of BC is equal to the gradient of a line parallel. Okay? It is equal to this gradient here. It is equal to the gradient of the parallel line. Okay? Let me say gradient of the parallel. Okay? I'll just name it the gradient of the parallel line, which is equal to how much? -1/2. Hey, this is free marks. So, okay, it is not necessarily free marks. It needs you to understand the concept. Remember now, for an equation, I need a what? A gradient and any point on that line. Which line? The parallel line. Okay. So remember there, for the equation of AC, we wanted a gradient and a point on AC. So a point on AC was A, but can you see also a point on this parallel line, which is A? It is what? It is A. Okay. So it is -2 and yeah. So I'm gonna say now for the last part, why? Can you see now the step is the same? For finding a gradient, you find the gradient of whatever that thing is. Then you find, you get that point they share, or the point that it passes through, then you substitute into this formula. Or for this one, let me use y is equal to mx plus c, so that people can also see that it's still the same. I can substitute y at which point? At negative 2 and 4. Okay, my point is negative 2 and 4. So I'll say, okay, 4 it is equal to, what is my gradient? Negative half. What is my x? Negative 2 plus c. How do I get my c? This is negative half multiplied by negative 1, negative 2, so it is positive 1. Then I take it to the other side, it becomes 3. Okay, let me do this math. And 4 is equal to 1 plus c. Then c will become 3, so that people cannot see I'm lying. So can you see why I'm saying c it should equal to 3? Then I do what I say, okay, fine. Therefore, it means my equation is y is equal to negative half x, then plus 3. Okay, I'm done. For 5 marks, how do I make this? Now I say 1 mark for this one. Okay, then seeing that the gradients are equal there, another mark. Again, for 5 marks, I give you here. Then now substituting the final answer. 5 marks. You are done. You are done. Cool. I want to believe you understood that one. I can move on, right? Yes. Now, you are given in grade 12, you won't see this. Where you are given an angle, you just need to use a calculator. You won't see that. But it's fine. If they're still giving you marks, it's fine. I'm told that if theta is equal to this angle and alpha is equal to 122 degrees, evaluate the following: round off to correct, of answer correct to 3 decimal. If you do 2, you get penalized. If you do 4, you get penalized. They want exactly 3. So what is sine A? I just punch this on a calculator. Just say sine, then put 122. You get how much? Sine 122. Exactly 3 decimal. I get 0.848. Then this one also arch. Tan, what is alpha? This is easy stuff and nice stuff. Please do not get this incorrect. On this one, you can say cos squared like that, or you can say, what is alpha? 89.4 plus 122 degrees. Don't forget the degrees squared. It's still the same thing, okay? This part, cos alpha plus beta squared, is the same as cos squared alpha plus beta. When you punch this on a calculator, it'll allow this format, okay? Yes. So how many do you get? It's just a matter of using a calculator. Tan 122 divide by cos. You just punch, you add them to get 89.4 plus 122. Then to those 3 decimal 1.875. Okay, yes, this one was straightforward. It was just a calculator skill. Okay, now the ones that I like. Okay, now I'm told that if 3 tan b plus 2, not b, if 3 tan beta plus 2 is equal to 0 and sine beta is equal to greater than 0, determine without the use of a calculator and with an aid. Now they tell you with an aid. Remember, what you should just remember it is you doing your cast. Let me do it here. This is what is needed. Remember here it is 0 degrees or 360 degrees. I have 90 degrees, I have 180 degrees, 270 degrees. Yes, right? Now, the first thing that you have to do, it is to evaluate this part. The 3 tan beta plus 2, you have to manipulate it. So it's going to be equal to 0 then. It's going to be 3 tan beta is equal to negative 2. Therefore, tan beta, it is equal to negative 2 divided by 3. This is what I'm interested in. Okay, tan beta being negative 2 divided by 3. Okay, now can you see now tan beta, it is negative. Okay, where is tan beta? Remember, Remember our cast diagram says what? Cast. Okay, tan is positive here and there. Okay, but now can you see how is our tan? Our tan is negative. Our tan is negative. Where is our tan negative? Our tan is negative on the sine as well as on the cos. Okay, remember I need two ticks inside one box so that I can know I draw in that side. Then I check sine beta is greater than 0. When they say sine beta maybe is greater than 0, they just tell you sine beta it is positive. Okay, so where is this positive? Where is sine positive? Remember, sine is positive on this quadrant as well as that quadrant. Which one has two ticks? This one. So it means whatever that you're gonna draw on that quadrant. I want to believe you're following. So it means your sketch will be on this quadrant. Let me remove this. Okay, then how are you gonna draw? I mean, this is your beta, and it goes like that. You can also draw this again there and say this is beta is fine, still fine. Okay, then remember what does beta tan? What is tan? Tan it is adjacent. So this is adjacent divided by opposite. Tower. Tan it is opposite divided by adjacent. Now I want you to be responsible of knowing how to align this negative. This negative does not mean it is for this 2. This negative, it is just here as 2 divided by 3, just thinking outside. Okay, so now I want you to see something. The y here is wrong, is positive. Can you see that the y here is positive, the x here is negative? So it means the negative sign is for the x. And remember, opposite it is y, adjacent it is x. Y, if this is my angle, opposite it is that. Can you see that this is y, then adjacent this is x? Yes. So what is my opposite? My opposite it is positive 2, not negative 2. Then what is my adjacent? Adjacent it is 3, but how is 3 on this part? How is my 3? It is negative. So now I need to find my r. How do I find my r? How do I find my r? It is 2 marks. This is 2 marks what I'm doing here. I'm not doing this because I'm bored or what. This is 2 marks. Then how do I find my r? My r here, okay? My r, I'm going to use Pythagoras. Remember, r squared is equal to x squared plus y squared. Then r is equal to square root of, remember r it is always positive. What is my x? Is negative 3 squared plus what is my y 2 squared. Then I have r as 9 plus 4. 9 plus 4, which is root of 13. So here I have what? Square root of 13. That's my r. Then now I'm done. I'm in a position of answer for this one, but I'll repeat. For this thing, it is 2 marks. Then we come back to our senses and now answer the question and say what is cos beta? Cos beta is equal to, you check. Cos it is cos, remember what is cos? Cos it is adjacent. So adjacent over hypotenuse. What is adjacent? Adjacent it is x. Here is my adjacent, it is negative 3. Divide by what? Divide by hypotenuse. Hypotenuse it is square root of 13. You are done. This is your cos beta. You are done. Then remember I said cos beta it is how much? Negative 3 divided by square root of 13. Then what is square root of 13? Cos beta minus sine. This one you also say, okay, square root of 13. What is cos beta? Cos beta we just found as negative 3 divided by root of 13. Okay? Like this. You close that one minus 18. Then remember I said this. Okay. What is sine beta? Now I have to look for sine beta. Sine beta is equal to opposite, which is 2, divided by hypotenuse, which is square root of 13. Can you see that? Yes. So it is what? 2 divided by square root of 13. But remember, there is that squared there. So you square that. I want you to see something. This will cancel this. Okay? When they cancel off, we get how much? Negative 3 minus 13 into. Now, remember these 2 will square this one and will also square that one. Okay? What is 2 squared? 2 squared, it is 4. What is square root of 13? Remember, if you have square root of something and you square that, remember, it will only just cancel that one and leave the answer. But you have a calculator, then can you see that this one and this one cancel off? Yes. Remember, I'm not using a calculator here. So I can, but after reaching this stage here, after being here, you can use a calculator, Shem, it's fine. I know you like calculator. So it becomes negative 3 minus this and this are gone, we're left with 4. So our answer, you're still continuing with equal sign. Our answer, it is negative 7. Okay, yes. Cool. Then let me move on to 3.3. On 3.3, I'm told that sine M, or sorry, sine 4 degrees is equal to M. So on these ones, I want you to draw this for yourself. Sine M is equal to 4 degrees, something like. Okay. Then M, remember what is sine? Just say this is over 1. Okay. Oh, so this is not M, it is 4 degrees. Okay. What is sine M? Sine M, it is opposite. Opposite to my angle. Let me try to enlarge that. Oh, okay. That is your 4 degrees, your angle. Then opposite. Remember, sine is opposite divided by hypotenuse. Okay. Then how do I get this? Remember, you use your Pythagoras. You say this one squared, it is equal to this one squared plus, then just you can call this x squared. But I want this one, it's going to be 1 squared minus, remember 1 squared is still the same as 1, minus m squared is equal to x squared. Then I square root both sides, x is equal to, and you see that 1 minus m squared. I hope I'm not too fast for this one. Then when I'm done drawing this, probably you'll get a mark, okay, for drawing this. Then now they want what? Tan 94. Tan 94. Remember, you're trying to reduce into a small angle, an acute angle. Okay. Remember, 94, it is big. So this you can make as tan 90 plus 4. Okay. Please respect the degrees. Okay. But now remember, we have what we call I don't know why this name, I always forget it. Okay, I've forgotten the name, but if we have something like tan 90 plus something, then also tan maybe 270 plus something, we call them, we have a special name for these things, okay? Then we're going to use that here. When I remember the name, I'll just yes, tell you. Probably you know that name. You are helping me out right now. Then if I do that, remember now I have to draw my Cartesian plane. Remember my Cartesian plane says to me, on sine, let me do this cast. This is the full diagram that you should know. This one, it is 360 minus theta. This one is just theta, or 360 plus theta is still the same. This one is 180 minus theta. This is 180 plus theta. This is also negative angle, also known as negative angle. This one is also known as 90 minus theta. This one is known as 90 plus theta. This one is known as 270 minus theta. This one is known as 270 plus theta. These are called cofunctions, okay? Yes, I now remember the name. Now the 90 and 270 are called cofunction, okay? But now the interesting part, remember, is that sine 90 minus theta changes to cos theta, okay? Then cos 90 minus theta changes to sine theta. Take notes. Sine, when I remove here, I'm done, is equal to cos theta. Then cos 90 plus theta is equal to negative sine theta. Why? These ones are easy because sine 90 minus it is on this quadrant and everything you change it positively. The one that is tricky is this one. Sine 90 plus theta it is cos a positive cos theta, right? So why? It's because now, can you see on this side? Sine is positive. So what I change is positive in there. So it changes to cos theta. But this one cos 90, man, how is cos in here? Cos is negative, so it will change to negative sine. If you're not sure, you can say, take your calculator and say cos 90 plus 8. You will get a negative answer. I'm done. I'm moving on. Okay? I'm moving on here. But now, remember, we do not have cofunctions for tan. Okay? Oh, I'm answering the question here. And I'm answering the question here. Okay? But remember, I do not have what? Something for tan. I'll just say this is tan. I can't say this is tan 90, tan 4. Instead, I'll say, remember what is tan? Tan it is sine 90 degrees plus 4 degrees divided by what? Cos 90 degrees plus 4 degrees. Then now I can say now this is sine. Remember I said sine 90 plus sine 90 plus angle, it is what? It is cos, sorry. It is cos for that angle. Then cos 90 plus, remember cos on this side, on 90 plus it is negative. So it will change it to negative sine 4 degrees. Then how do I know how much is cos 4 degrees? You come here and say now I have an angle 4 degrees cos it is adjacent. So this is adjacent and this is hypotenuse. So what is cos for cos 4? It is square root of 1 minus m squared. Can you see that? Divide by 1. Divide by 1. I'm going to use this divide. All divided by, what is sine 4? Negative. What is sine 4? Sine 4, remember, you are given as how much? As m. So negative m. So this is the same as saying now, this is, remember this side, everything divided by 1 is just that part. 1 minus m squared, and take this division into a normal 1 minus m. I can put this minus here. Okay? Yes. You can also say it's minus like that, like here. You can also use this division like, but it should be the longest division, and now divide by what? By negative m. But can you see this one will fall into just square root of what? 1 minus m squared divided by negative m. So this and this are the same answers. Good, good, good. I'm done. I hope you are following. I've tried to explain this as slow as possible. Then what I have to do, remember this triangle is very important. I won't remove it. I'm doing trigonometry. I won't remove it because it's very important. Okay, the cast diagram, you should know it off by heart. This one. You should know it off by heart. Okay, Now, let's move on to the interesting one, 3.4. Ish. Okay, before I come here on 3.4, I want us to come back to this equation again, okay? There is another method that you can use. Instead of using 90 plus and what, if you feel like it's confusing for you, you can say, okay, tan 94 degrees, it is equal to what? You can use 180, okay? You can say this is the same as tan. Okay, you can use sum of angles in a triangle here and get this angle as 86 degrees, okay? Sum of angles in a triangle. Good. Then you can say this is tan what? 180 minus 94. Can you see now? You're going to get how much? 180 minus 94, you get tan 86 degrees. Oh, sorry. What? Yeah. What angle minus what angle? 180 minus what angle should give me 94? You can say 180 minus 94, it will give you 86 degrees. Then this will be the same as tan. Okay, how is tan in this quadrant? How is tan in this quadrant? Can you see on 180 minus tan is negative, only sign is positive. So this will be negative tan 86 degrees. Then you can come here and say, what is tan? I have an angle 86 degrees. What is tan? Tan, it is opposite. This is opposite, okay? Opposite, how is my opposite? My opposite is square root of 1 minus m squared divided by, what is my adjacent? Adjacent, it is this one, m. Remember, don't forget the negative like that. Do you still remember you also got the same answer like that one? So it was another step there of, hey, now I want us to move into an interesting stuff. This one, it is 5 marks, right? I do not want you to get 0 or yeah. At least when you have failed, get at least, I don't know how much. But I want you to get full marks. This one, how do I evaluate this one? This one is 360 minus cos 360 minus. You start first by locating 360 minus, it is on which quadrant? Let me remove these ones. They will confuse you. I feel like my thing has shifted. Okay. Can you see now 360 minus, it is on this quadrant. Then how is cos in that quadrant? Cos is positive. So cos x multiply. This is multiply, right? And x minus 180. This you can rewrite as, remember tan x minus 180. You can rewrite as tan negative 180 plus x. Or, okay, if you have x minus that one, that is written like this. If you do not want to stress yourself, just add 360. You'll see. Just add 360, you'll see. Okay? When you add 360, you get how much? Tan x plus 180. Remember, if it is plus, you can write it as 180 degrees plus x. So this you can say it is tan 180 plus x, okay? Or if you do not want to do these steps, a lot of steps, just take your calculator, okay? Take your calculator and say tan of any angle. Just put 30 instead of x. Just put 30. 80 minus 180. Can you see that the answer that you get, it is square root of 3 divided by 3. It tells you that the value of x here, it is positive. So you can just say this is tan x. Okay? This is the same as, and why am I saying, and why is it positive? Can you see on 180 plus, how is tan? Tan is positive in there. Remember cast, tan is positive in there. Then this is multiplication sign, the dot, divided by sign of negative angle. Remember I said negative angle, it is on this quadrant. If this is positive angle, this is negative angle at the bottom, okay? At the bottom. Or do not stress yourself. If you feel like this thing is something that you do not know, just say, then just add 360. If it is written in a way that is weird, x minus something or negative x, just add what? 360. This is the same as sine 360 minus x. So 360 minus x, it is on this quadrant. How is sine in there? It is negative. So it is just you saying, okay, this is negative sine x. Can you see how nice? Cos 90 minus, remember this is what? Co-function. Okay? Do not try to add 180 here, and 360 here. You'll get another co-function. You have to remember your co-function. So this is where I say this is 90 minus angle. Okay? So this one, how is cos in this side? It is positive. So it just changes. Remember the co-function changes to sine. So it's going to be just positive sine x. How interesting. Sorry. So it is equal to negative. So it is equal to, then what is this? I can just say cos x. Remember, we do not want tan as it is. So this, it is sine x divided by cos x. Can you see? I see something. Then negative sine x multiplied by sine x, it is negative sine squared x. Okay? Now, can you see that these and these cancel? If I have something like a divided by 4 multiply, this is a, not 9, a multiplied by 4 and 3 divided by a, this, the numerator and the denominator will cancel. Okay, yes. In this case, we have something like over 1. So this will cancel, this cos will cancel that cos, and we'll be left with only sine x minus sine x divided by 1, which is the same as sine x. So in here, I have what? Sine x divided by what? By negative sine squared x. Can you see now? I have 2 sine x here at the bottom. I have 2 of them, but here I have 1. So I can say this one will cancel 1, will cancel one of these. Okay? So remember, negative sine squared x, we got it from what? Negative sine x multiplied by sine x. So I can cancel this sine x with one of the sine x. Can you see I'm left with what? Negative sine x, yes. Which is the same as when you cancel something, it is not 0. When you cancel something, it is not 0, it is 1. Divide by, this is negative sine x. I am slow. I want you to understand this. I'm done. 5 marks. For 5 marks, how do they mark this? Now, for changing the numerator, changing the denominator correctly, then changing tan here, I think I think final answer will get mark. Then for simplifying here, you get a mark. 5 marks. These questions can be 5, 7 marks. Like they can be a lot. They can be a lot. All right. Now, evaluate without using a calculator. I also like these ones. This is where you have to use reduction. Here it was easy because you looked at this and say, okay, it is positive in there. But on these ones, what you have to do, you have to reduce them, okay? You have to reduce this into a single angle. Sorry, not single angle. An acute angle or small angle that is less than 90. So this will be tan 180 degrees. What is it that I can multiply? I can subtract 120 with to get this one. I just say 180 minus 120 to get the answer that you need here. Multiply by sine 180 minus 180 minus 115. I get what? I think 75 or 65. Okay, I get 65. All divided by what? Cos 240. Cos 240, this one and this one are double angle. You'll see when you reach in grade 12. Cos 240, I can say this is cos 180. If it is less than 1, okay, if your angle is less than 180, just say 180, you're going to use this 180 minus whatever that angle, okay? If your angle is greater than 180, It means you'll use what? 180 plus whatever this value is here. So can you see this one is less than 180? I use my 180 minus. This one is less than 180. I use 180 minus. This one is greater than 180. I use 180 plus. But mathematics is fun. Yo, mathematics is fun. Yo, all right. 180 plus 60. Do not forget these degrees, people. Multiply by cos 2 cos. Can you see it is greater? 180 plus 180 plus what here? Plus 45. Okay. I want you to, okay, let me simplify this. So this we agree tan 180 minus, it is negative in there. The tan, it is negative in there. So this will be negative tan 60. Multiply by sin 180. 180 is joined in there. This is multiply. This is multiply. 180 it is positive, so will be multiply by, where are you taking my dot? Sine 65 degrees. Divide by what? Divide cos 180 plus. How is cos in this 180 plus quadrant? It is negative, so it will be negative cos 60 degrees multiply by cos 180 plus 45. How is cos in here? It is negative minus cos 45 degrees. Good. Nice and enjoyable. Now I want you to see something. I want you to see something. Okay, let me quickly do this. Okay, I've quickly drawn our special angle here, right? Triangle. Now, okay. I see a mistake here. When I reduce this will be 180 plus 25, okay? This will be 25 instead of 45. Please bear with me. Sorry for the mistake. I do not like making mistakes. It causes confusion. But yes, I want to teach you something, okay? If beta, let me say if alpha plus beta, it is equal to 90 degrees. If these two are complementary, we say they are complementary. If these two are complementary, then sine of this angle is equal to cos of that angle. I repeat, this only works if this angle here, it is this, when I add this plus this, they give me 90. Then I can say they are equal. What do I mean by that? Okay, let me do an example. If I have sine 45 degrees, sine 45 degrees, it is equal to cos 45 degrees. Why? Because this angle plus this angle, they're equal to 90. How can I prove that? Remember, I have a triangle that looks like this. 45, 45, 1, 1. What is cos sine 45? I can use this one and say this is opposite. Can you see? It is what? 1 divided by square root of 2. 1 divided by square root of 2. It is equal to, let's check if it is equal to cos 45 now. Cos 45, this is adjacent. 1 divided by hypotenuse, square root of 2. Can you see they are equal? Yes. Another thing I can use again is if I have sine 30. Sine 30 will be equal to cos mang. I want an angle such that when I add to 30, it gives me 90. That will be how much? Will be 60. So, can you see? 30 plus 60 it is 90. So, if that's the case, now what is sine 30? We are proving sine 30, it is opposite over hypotenuse. That one sine 30 should be knowing by now. It is equal to half. Cos 60 was adjacent to 60. Okay? Then hypotenuse, it is half. Can you see that? Yes. Now, why am I teaching you this? I am teaching you this because sometimes you have something like this. Something like sine 30 divided by cos 60. You want to eliminate them, but you do not know how. You can change, however, you can change this one into cos. Remember when you change it, you change the name and as well as the angle. Remember, this is equal to that one again. Divide by, you do not change this one. You cannot change. When you change this one, can you see you're causing yourself a confusion? You just change one of these. So it will become cos 60. Then you can cancel them nicely. Or you can leave this as sine 30. Divide by only if this and this are equal to 90 degrees, okay? Then can I change this one? Yes, into what? I change the name to sine. The angle that 90 minus this angle, it is 30. Can you see now they are the same? This and this are cancelling. Okay. Okay. Every time when you are facing that, oh, I'm going to need this. Every time when you are facing that, just remember that one, okay? I'll remind you. I'll remind you also. That's fine. It's no big deal. Okay. Okay, this is the equal sign here. Then what is negative? So negative tan 60. I come here, I say this is 60 degrees. Tan, what is tan? Tan is opposite. Okay, what is opposite? Remember it is negative square root of 3 divided by adjacent. Adjacent, it is how much? It is 1. Then I multiply by how much? By sine 65 degrees. Okay? This is the same as square root of 3 only. Okay, this is the same as the negative square root of 3. Divide by. What is negative cos 60? So it's negative. What is cos 60? Here is 60. Cos, it is adjacent. Adjacent, it is 1. 1. Hypotenuse. What is our hypotenuse? It is 2. What? Multiply by negative cos 25. Okay? Now I want you to see something. This negative and this negative, when you multiply them together, they will give us a positive. So I can say this is just half cos 25. Now the question is, how can I remove this? Okay? How can I remove this? One thing I check first is that, is this angle plus this angle equal to 90? Yes, 65 plus 25 is equal to 90. If I can change one into the other, what do I mean by that? What do I mean by that is that I can say this is negative square root of 3. Multiply, I can change this one into that one. What do I mean? I can change this one to cos 25 degrees. Divide by what? By half. This one you leave it. You change one of those. Do not change two. What a exam. You'll go crazy. Then now I can eliminate this and this. Okay? Or you can say negative 3. Then you leave this one as it is, sine 65. Divide by a half. Then instead of changing the top, you change the bottom into sine 65 degrees. Can you see? Now we are getting the same thing. So this is square root. Okay. So the answer will be square root of 3 divided by this. You can punch this on your calculator. You'll get negative 2 square root of 3. Okay? I want to believe you are following. I am slow. I'm not in a rush for 6 marks. How do I get that 6 marks? I get that 6 marks for reducing the top, the bottom, special angle on this one, on this one. Okay? Can you see that 4 marks already? Then changing one of these, changing this into cos, or changing the bottom into sine. Okay? Then the final mark. Can you see that? I am slow. I am slow. If I was writing this question paper alone, I could have been in maybe question 6 right now. Don't know. But yeah, I'm just showing you that I am explaining here. I'm not here and say, okay, this one, I said, and 4 plus 5, which is equal to and 9. That one you learned in class. No. I'm teaching you because I do not assume that you know it. I assume that you know it, but you are struggling with it. So I'm trying to lay a much foundation thereof. 3.6. Prove the identity. I like identities. Why? Because yes. How? What do you mean by that? I mean, of course. Okay. Now, here you have 1 divided by 1 minus cos x plus 1, sorry for the bad handwriting. When you are trying to prove, you'll say left-hand side, okay? Remember, you're trying to prove the left-hand side it is equal to the right-hand side, the complicated side. Just say left-hand side is equal to this one plus cos x. You do not say equal. You are trying to prove the left-hand side. Then you say equal sign. Then you check here. Can you have the LCD? Remember, if you have 1 divided by b plus 1 divided by c, the LCD, it is b multiplied by c. The LCD, it is b multiplied by c. Okay? So similarly, here the LCD will be what? Will be this one multiplied by that one. Okay? Plus cos x. This will be my LCD. Okay, yes. So it means, can you check this one? It has 1 minus cos x. It is short with 1 plus cos x. So I'm going to multiply that one by 1 plus cos x, like that. Okay? Plus, remember there will be under one denominator, which is now in case 1 minus cos x, 1 plus cos x. Then I multiply. This is the same as saying this multiply by that, but and this multiplying by that. After finding out the LCD, you can do that. You can say this multiply by that. Can you see it still give you the same thing? And this multiply by that. Can you see it's still the same thing? So multiply by 1 minus cos x. So let's try to simplify a little bit further off. This will be 1 plus, we're removing the bracket, so bracket, plus 1 minus cos x. Can you see that? Divide by, can you see now already cos x minus cos x will cancel off. I already have 1 plus 1, which is 2. Can you see I'm one step closer? 2. But now, can you see at the denominator I have this with cos? So how can I remove that? Let me try to multiply out. Can you see this here? This is a difference of 2 squares. What do I mean by that? You remember, if I have a minus b into a plus b, this will be the same as a squared minus b squared. Difference of 2 squares. You square the first one, then you square the last term. Then remember the sign negative by positive, it is negative. So what do I mean by that? I mean that I square the first term, it will be 1 minus I square the second term, cos squared x. Yes, it is equal to 2. Remember this and this cancelled off. 2 divided by, I'm taking this slowly. I could have done this once off. I want you to show you. Can you see now? Instead of having sine x, we are having what? Cos x. That's not what we want. But remember, I have this part, a square identity that says to you, that one we were happy for. is equal to 1. So now, in this case, what do I have? I have 1 minus something. So 1 minus cos. So it means I take in the cos to the other side. So this is sine squared x. It is equal to 1 minus cos squared x. Can you see? This is what we have. Can you see? But what is that equal to? What is that equal to? That is equal to what? To sine squared x. So this is equal to 2. I substitute this with sine squared x. Sine squared x. I want to believe I explained this. First mark, it is the getting LCD. Okay. Second mark, it is simplifying. Okay. Then the third mark, it is using the identity. Okay. 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 I think I'm not fast nor too slow. So yes. Okay. Let's move on to. If I'm too slow for you, please do listen this video in 1.2 or 1.5 or 2 if you feel like I'm too slow, low, yes. But if you feel I'm too fast for you, do not use 0.5. I'll talk like this. Sin x plus 2. So no, if I'm talking too fast for you, just try to go back to the video again and rewatch, okay? Because when I talk sin x, you'll fall asleep. Okay, we have proven that. Now we are coming to what we call the what general solution. Remember, on general solution, we have what we call general solution. This is what we have. And we also have the specific solution. The specific solution is when you are given x is an element of from 0 to 180, maybe something like that. Yeah, but okay, sharp. Determine the general solution for this one. How do I tackle that? I'll say, first thing first, let me try to zoom this out for us so that you can see. I'll say this is 5. Okay, I'll divide by 5. I'll divide by 5. This will be so man. Tan. Okay, it is equal to 5 divided by 4. Check. The question did not say, the question did do not. Right. I'm teaching you. Do not try to solve for theta. Do not do this. Why? Because it is a general solution. Do not do this. Do not say arctan. Do not say therefore theta plus 10 it is equal to arctan of 5 divided by 4. Then you get do not do this. This one you only do in grade 10. Grade 10. Where they say solve for theta in grade 10. In this case, they say general solution. So for general solution, you should have 2 solutions, 2 or more solutions. Okay? Take note of that. Now, how can I use this? So what I'm gonna do, I'm gonna say, okay, and I'm gonna first find my reference angle. My reference angle, that's when I can say tan. For my reference angle, sorry, my English is going away. For my reference angle, I can do this. Then my reference angle is tan of 5 divided by 4, which is something like 51.53. Can you see, I did not say theta plus 10, it is equal to arctan. I said my reference angle. My reference angle. My reference angle, it is everything here, but I do not write it like that. So I say my reference angle is that. So what I do, I'll have to choose 2 quadrants. How do I choose 2 quadrants? I come here to my back, to the original equation here. How is tan there? Can you see that tan something? It is what? It is this one. How is tan there? Tan is positive. Can you see that this is positive? So now, reminder, where is tan positive? Remember, on our cast diagram, where is tan positive? Tan is positive on this quadrant, on that quadrant. So we're going to say we want to go to the quadrants where tan is positive. Okay, tan is positive on quadrant 1. We'll look at quadrant 1. As well, and we'll look at quadrant 4. Okay, then what do I do when I come there? When I come there, the first thing that I start with, it is this one. I start with that one. Similarly on this one, I will start with that one. I'll say theta plus 10, which is equal to, on quadrant 1, what do we say? Remember, it's just that angle, okay? What angle? Reference angle. 51.34 plus K. Now we are talking about tan. Tan, when you draw the graph of tan, what is the domain? Sorry, what is the domain of the graph of tan? Do you all agree with me that the domain of the graph of tan, I've forgotten how to continue this. Okay, the domain of graph of tan, it is 180, because why? This is the shape, this is the one. After that one, it repeats the same thing. Can you see? So here, remember the domain is where it completes the full cycle. So it is one like that. Come in. Sharp, sharp. Okay, I'm not 31. Okay, now hands. Sharp, sharp, put. Sharp. Ja, ist klar, Interview. Okay, thank you. Yes, as I was explaining, sorry about that. As I was explaining that the period for tan graph or normal tan graph, it is what? It is 180, right? So we'll just say 51.34 plus k 180 degrees. Then do not forget k is an element of real numbers, okay? This is something like this. Yeah, something like that. I do not know how to do it, so I use this one. It's fine. They won't penalize you. K is an element of, yeah, do it however. It's fine. Okay. Then also here, remember this one, I also start with it. Theta plus 10, it is equal to what? Here on quadrant 4, what do we say on quadrant 4? So this was supposed to be quadrant 3. Remember, tan is positive in quadrant 3. So what do we say in quadrant 3? In quadrant 3, we say 180 minus plus. Okay, in this quadrant, we say 180 plus the reference angle or the angle, which is theta. So the angle, which is the reference angle, it is how much? 51.34 degrees plus k 180. K is an element of integers. If you encounter a problem where you have to divide by 2, you also have to divide this. This is also divisible by 2, so it will be k 90 when you divide by 2. If you divide by 3, you divide it also, okay, yes. So now let's simplify. I want to solve for theta. Here I can solve for theta. Remember I said your solution should be 2 or more. So I can say theta it is equal to, when I take this 10 to the other side, it's going to be 51.34 minus 10, which is 41.34 degrees plus k. I do not subtract here. Even if you do not write this one for now, because you already encountered accounted for it here. Okay? So here you just say theta, it is equal to, when you take this 10 to the other side, it will be 180 minus, 180 plus 51.34 minus 10, which is 221.34 degrees. So yes, plus k 180 degrees. Then you can say k is an element of real numbers. You can leave it, it's fine, but yeah, so that you do not forget it. This one is not compulsory. Okay, yes. So this is what they mean when they say determine general solution. Okay, yes. Okay, let's move on. Question 4. This one I like it when they say sketch. I like it when they say sketch because I already know I have that 6 marks. Easy 6 marks. I'll show you. Trust me. I'm here to make your life easier, right? Yes, of course. Then why not? Why not? Why not? Okay. Now, first thing first, I have f sine 2x. The second one, I have 3 cos x. Now, I want you to explain something. The graph, it is y is equal to, let me say, a sine x. In grade 10, it was a sine x plus q, where this was your amplitude. Okay? This was your amplitude. This was your horizontal shift. When you say horizontal, we mean up or down. Okay? Then, in grade 11, we introduce something. Now we say y it is equal to a sine b x minus p plus q. A is still your amplitude. Q is still your up or down movement. B, it is now what we call your period effect. B, it is what we call a period effect. I call it period effect. If you have something like sine 4x, maybe. Yeah, let's say y is equal to sine 4x. This is your B. Remember, check, in this case, we do not have, it is like minus 0. Okay? that one, the bracket. So it is just sine x, 4x. So this is your B. It affects, remember the period for sine, for the normal sine, sine x, the period it is 360. But now if it has 4x like this, your period for this one, your period will be what? The normal period, which is 360 divided by B. This is your new period. Okay. Then here on the x, remember this one, it's either it goes up or down. This one, if it is negative p, it goes to the right. If it is negative. If it is positive p, it goes to the left. Meaning if I have sine x plus 45, I shift 45 to the left. If it is sine x minus 45 degrees, I shift 45 to the right. Why? Can you see? I want you to take this one. Why am I saying it's going to shift to the left? Because this one, it is the same as x minus 45, which is equal to 0. Just equate it to 0. X is equal to 45. Can you see that your x here, it is positive, so it tells you it moves to the right. Similarly, for that one, you'll get a negative answer. Therefore, it will tell you that you have to move in the negative direction. Okay? Okay. Now, let us try to answer the question. Remember, what does this A is your amplitude. If this is a normal sine at 1 and negative 1, if your this is for y is equal to sine x. So if now your graph has changed to maybe y is equal to sine x plus 3, can you see all the points will move? This one will move. This one is 0, it will move to 3. This one is 1, it will move to 4. This one is 0, it will move to 3. This one is negative 1. When you add 3, it will move to 2. Then this one will move there. So it will be something like a new graph. It goes there, it comes back, it goes there, it comes back. Can you see when I remove that? My new graph, my new graph. But yeah, okay, it's fine. I think I've explained enough now. I'll record a video where I explain trigonometric functions. They are not that difficult. Okay. And sometimes in high school, they do not like to teach them very well. And they are not that difficult. So here we have f of x is equal to sine 2x. So the period here will be 180 degrees because y of 2. Remember the period mu will be what? 360 normal period divided by 2, which is 180. Then here the period is the same. The period I is still 180. But now can you see now the amplitude, it is now 3. The amplitude, it is now 3. And remember the cos graph is like this. So it will be at 3 and negative 3 due to this amplitude. It is no longer 1. If it is like this, it was going to be like this. At 1 and negative 1. If it was just cos x, I will sharp. Now, I want you to, they say, sketch the graph of f of x and g of x on the same set of axes in the given interval. Which interval? Negative 90 to 90. Okay, sharp. I want you to draw. The first thing that you should have, it is a very, very good rule. You should be very precise with your measurement. You'll see, Mara, as in June, you are supposed to be given you'll be given a what sheet. I can't remember it. An answer sheet for paper 2. For paper 2, you have an answer sheet, okay? Let me draw a big one so that you see a neat graph. Let me see. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 1, 2, 3, 4, 5. Somewhere here. Okay. Or I can do my divisions again and rotate it again. I'm trying to do a straight line here so that I have a very nice and let me quickly do that. Ungajabuni sitazami. Okay, I have drawn that. Now one might wonder, why have I drawn this graph like this? Why here is it negative 90, 45 instead of maybe negative 90, 30, negative 30? It's fine, you can use that, but yeah, I feel like these points are the ones that I need. Then here, how did I know I'll have to use 1, 2, 3 up to 3? Because I checked that one of my functions. Can you see one of my function? The amplitude it is 3. So I know it will be at 3 and negative 3. Yes, the period it is 160. Okay, now how do I draw the graph? I want you to do this. Do yourself a table. F of x. Uh, okay. X, f of x, g of x. I want you to see this. The first question you should ask yourself is how many x coordinates do I have? Can you see I have negative 90, negative 45, 45, and 0. Do not forget the 0 here. So I'll say negative 90, negative 45, 0. Do this on your scrapbook or somewhere. The examiner does not want to see this. The examiner does not care how you use, whether you use a calculator to draw, whether you use a method like mine to draw. The examiner does not care. What the examiner is interested in is your values. Okay, the blue one will be into f of x. Remember what's the function of f of x? Sine 2x. Okay, what I'll do is I substitute now x as negative 90. Or can you see that x as negative 90? So I'll say sine, there will be a bracket, just say 2 multiplied by negative 90. You get how much? 0. Then substitute negative 45, you get negative 1. Substitute 0, you get 0. Substitute 45, you should get negative 1. Or it's positive 1. Then you substitute 90, it's 0. Good. I come here. Substitute this one on the cost graph. 3 with 3 cos what? I just put fella negative 90. I get 0. Negative 45. I get something like 3 divided by, okay, 3 square root of 2 divided by 2. Just do that as 2 comma 1. Okay, approximate it to 2 comma 1. Then I have 3, 45. I have that number again, 2.1. Then I put 90. I get 0. Then it's just a matter of me coming here and saying, now I'm plotting my graph. How, Mpo? Like this. When x, I'm gonna first look at this. This one and this one. This one and this one. This one and this one. Then when I'm done, I'll show you. Then I say, okay, I'm gonna plot it f of x, the blue one. I'm gonna say at negative 90. When x is negative 90, y is 0. When x is negative 45, y is negative 1. Like that. When x is 0, y is 0. When x is 45, here y is 1. When 90, when x is 90, Y is 0. I try. Remember, I know the shape. I'm expecting a shape of some sort. Remember the shape of sine, it is something like, okay? But if I have an extension like that, means I have something like that. But now, can you see, I only want this interval from what? If this is 90, I'm lying. If this is 180, and this is 360. But remember, the period is no longer 360, the period is 180. So it means there will be half. This will be 180 and 90. But now I only wanted this section. But it's easy, just join the points. Just like that, I've tried. Then I come to what? To negative 90 and 0. I'm plotting the g of x now. Okay? Negative 90 and 0. There. Negative 45. 2.1. Negative 45. 2.1. Somewhere a little bit above 2. 0 and 3. Do not confuse this. 0 and 3. When you are done with these blocks, you can like that so that you do not get confused. 0 and 3 there. When x is 0, y is 3. 45, 45, 2.1, 45, 2.1, 2.1. We said it is a little bit above here. This point and this point should be equal. Then 90, 0. What I just do, I join the pattern that I see now. This is what I see. Perfect. It's like some shape. Can you see? Do you know this? I don't know if you wear a necklace. I do not, but I know this one necklace that's like this. Then this part it is black, and this one is white. Yeah. Either way, we're not there. So remember, this is your. I'm removing this table of mine. Okay. This is my X. This is my Y. Oh, I like my graph. It is so perfect. I hope yours also becomes this perfect. Now they say what? Sketch on the same set of axes given. Show all the coordinates of the intercept and the turning point. And the turning points are here are the turning points here. Turning points here at negative 1 and 45 and 1 and it's fine. My graph already shows that. Now, I'm done for 6 marks. What am I doing for 6 marks? Just award you 3 marks for this one and this one. Just 6 marks. Make sure that you take that 6 marks. When you come here, it becomes easy. If you get something wrong here, yeah, high chances that the answers that are gonna follow are gonna be wrong. Cool. Now, write down the period of f of x. Okay. Now we check f of x. Now here is f of x. Remember, if this was sine x, the period was gonna be 360. But now it is sine 2x, so our period is gonna be 360 divided by 2, which is 180 degrees. The examiner is only interested in what? Did you see how I got the 180? You say 360 divided by the coefficient here. Here the coefficient is 1, so the period is still the same. So 180 degrees. Write down the range of G. Range of G. Where is G? Remember what is range? Remember, range, it is minimum to maximum. Okay? This is what range is defined as. Now, let's execute that. What is our minimum value of the G graph? One thing that you should do, it is labeled, this is your G graph, this is your F graph. Okay. Now, your minimum, it is the lowest value. Can you see now? The lowest value for graph of G, it is 0. We are talking about the Y value, the lowest Y value. It is how much? It is 0. So we're gonna say Y is an element of minimum, it is 0. What is the minimum? The maximum value, the highest value it can reach, it is 3. Can you see that? Sorry. Can you see that? Yes. So it is 0 and 3, just like that. Good. 2 marks. For which values of x will f of x multiplied by g of x be less than 0, be less than or equal to 0? Now, these questions are interesting. They mean now, when I multiply this, the y value of y value of f and multiply by the y value of g, it will give me 0. So it means I want to where this one is, okay, where f of x is negative, I'll draw this. Where f of x is negative, where g of x is positive. Can you see negative? Remember this one means less than. Means less than 0 means negative. Less than 0 means negative. So it means when I multiply negative by positive, okay? Or when I multiply positive by negative. So I'll say f of x and g of x. I want those points. Okay? Where f of x is positive and g of x is negative. Okay? Now, I want you to see something. From here, let's talk about f first. Where is f negative? We want where this is negative, this is positive, or this is positive, this is negative. We are trying to see that. Where is this f of x negative? F of x is negative here. There. Okay, from negative 90 to 0. Okay? We know from negative 90 to 0. Where is g of x positive? G of x is positive everywhere. Can you see that? Actually, this is not important. Okay? Actually, even you don't need the table because the table will confuse you. Okay. Now we want where this is negative and positive, okay? So where is that? It is here. F is negative there. Let me erase that. F is negative. Let me also erase this. F is negative here. Can you see that? Where is G positive? Positive everywhere. Okay? So, but now we want where both of them are negative and positive simultaneously at the same time. Where is that? Can you see at this point? I don't know which color to use. Can you see at this point? This section here is negative and positive, negative and positive. They are different. Can you see that? Only on that portion, but starting from here, can you see now, not both of them. Not, this one is only positive and this one is positive also. So the first solution that we want, it is when the first solution we want, it is what? When x, it is between what? Negative 92 to 0. Okay? This is the first condition, negative and positive. Now let's look at the second condition. Let me do this. Again, let me try to, oh my God. Okay. Ooh, it was so smooth. Okay, I just knew it. Okay, we said for this one, we saw that it was this part, right? Here. There. The other one, G is positive, F is negative. So we said the first one, it is X is an element between what? 90 degrees to 0 degrees. Now, we are using these brackets. These brackets. Why? Because the examiner said less or equal. Or if you do not want to use this one, you can say there is an interval for you. You can say x is between, oh, sorry, this is negative 90. Negative 90 and 0 degrees. Sorry, this is negative 90. Okay, let's want another interval. Let's look at other possible solution. Where f of x is positive, it's here. Where is f of x negative? We do not have that. Sorry, g of x is negative. There's no way where g of x is negative, right? So yeah, it will just end there. So the only one that is corrected is the above one. So it means the correct answer of it is only this one. It means it is only this, sorry, it is only this part. Okay, yes, I want to believe you are following. Let's move on. Question 5, then question 6. Okay, then now we are done. Question 5, then question 6. Okay, now question 5 says to us, am I not skipping anything? Okay. Complete the following theorem. Okay. A line drawn from the center to the circle is perpendicular to chord. So a line drawn from the center of the circle, perpendicular to the chord. Okay. Let me quickly draw that for you. Rainbow ending. Okay, it's fine. They say a line drawn from the center of the circle. Okay, can you see the center of the circle? Line drawn from the center of the circle. Perpendicular to the chord. Now we'll have a chord. Can you see a line drawn from the center of the circle? Here's that line. Perpendicular to the chord. What does it do to the chord? It bisects the chord. Okay? Okay, it bisects the chord. A line from the center of the circle, perpendicular to the chord, it bisects the chord. Okay, if I'm told this is perpendicular, it bisects the chord. Yes, you can look at the proofs under a Euclidean geometry a video there. I have a playlist for that one. If you're not sure about Euclidean geometry, you can watch those. Then we say it bisects the chord. Good. Now we are looking into an interesting stuff. Okay. Oh, okay. Oh, in the diagram below, sorry, in the diagram below, O is the center. Very important. O is the center of the circle. And AC is the diameter. Okay, I have the first thing that I collect. I like to collect that. Let me collect it on this side. We have center. Remember, we have center theorems, hence I'm collecting center. We have what? A diameter. AC, a diameter. I'm not collecting this data for Mahala. Before I even look at the question, I'll try to answer the questions there. You'll see how I do this. Then AC is produced to meet ED. AC to meet ED at G. Okay. This is not a tangent. This is a secant. OE, then here. So what's this? Let's look at that. OE. OE, okay, and CD. Can you see those lines? They are parallel. So basically this was parallel. So now we have parallel lines. We have what? OE parallel to CD. Cool. And B is equal to 72 degrees. Can you see that? Cool. Now, before I look at any questions, I try to use this information I collected here, the center and the what and the what. Okay, let me try to use the center. What theorem do I know about the center? Okay, line from the center is twice. Okay, angle at the center is twice angle at the circumference. Okay, let me look at the angle at the center. Okay, if I move, okay, I can see one is angle at the center. Okay, so I want to see which angle line subtends that. I move like that. I move like that. Okay, do this subtends any angle? Where is A subtending again? A subtends there. Does E join there? No. Can you see E goes there? So angle at the center does not apply for that one. Okay. Another thing that you can see is, okay, if this one goes there, it does not apply. But if A can go into that way. Let me remove this. A, can you see it is joined into three ways? So it can go into three ways. So if we say it is like that, it can go that way. It has already gone that way. It can also go that way. It can also go that way. Okay. So let's try it. When it goes that way, it's gonna be like that. Sorry, let me repeat that. Can you see that? Then E is joining. So this is the circumference. So one thing I can see is that, okay, angle O1, it is twice angle D4. This is me looking at the center first. I haven't done anything. Another center I can see, let me see. Okay, I do not have any angle there. I did not name it, so it's fine. I can ignore it. This is not a cyclic quad here. Why? Why is that not a cyclic quad? Because this is a circumference, okay, sharp, circumference, sharp, sharp, circumference, but this is not a circumference. Okay? Let's look at the other thing. Okay, before I look at the circumference and what, let's come, this one I'm done. Let's look at the diameter. Okay, if AC is a diameter, what do you know about the diameter? The angle subtended by that diameter. So AC can go there, and this one can come in here. So you all agree with me that angle D2 plus angle D3, it is equal to 90 degrees. This is me answering the question there off. Can you see that? Yes. A. Another thing that, okay, I'm done with the diameter. Okay, I know about the diameter only has one thing. Then I'm told OE is parallel to CD. If these two lines are parallel to one another, what property can I use? The property I can use it now, it is what? Corresponding angles. If I extend this line like that, can you see? Now I have what? Angle E2 being equal to this angle being equal to angle D1. Okay, yes. The reason we'll see the reason. The reason we'll use. Or I can also put the reason so that I do not struggle. Angle in the semicircle, I'll do this. Then this one corresponding angles. I'll remember which two lines are parallel. Am I done with those parallel lines? Let me see something. Am I done now? Can Z shape come out here, alternating angles? No. No alternating angles like that. Can you see there's no line like that or line like that? So the other thing that you can use is that, okay, this angle here and this angle here will be equal to 90. Why? Because we know this angle here plus that angle will be equal to 90 because co-interior angle. Okay, I'll remember that one. Angle E2 plus D1, D3, D4 equal to 180. Why? We're saying co-interior angle. I'm done analyzing what they have given me. I come another thing, I see something, I can see, can you see now? If I'm not mistaken, I can see something like a shape like this. Okay, let me try to analyze that. If I move from B to A, and then from A to E, then from E to D, from D to B. Okay. I can see I just found an information that was not given to me, but I can see what a quadrilateral. This is the additional information. Is it that I can be asked to prove that it is equal to whatever, or I'm going to use it? So if this is a quadrilateral, remember it is a quadrilateral because it touches the circumference again 4 times. Then it means this angle plus this angle, they are equal to 90. What does this mean? This means now this angle E1 plus E2, it is equal to what? 180 minus 72. 180 minus 72 degrees. I'll remember that. Opposite angles of cyclic quad. Another thing I can use, exterior angle. This angle. If I extend this line here, please watch my video under what's this? Euclidean geometry so that you understand what I'm doing here. And I'm going to say this angle here, it is equal to the opposite. Can you see? Interior angle like that. So, okay, it is equal to that. I'm done. It's fine. I can look at the questions now. Hopefully, the questions that I've answered here, they will appear. Hopefully. Another thing I can see, remember, please, if you have a complicated thing like that, please try to look out for this part, the bow tie shape, okay? Please try to look out for that one. Okay, I can see some here. If you have a complicated thing like that, please try to look out for that bow tie shape, okay? Can you see now? I see one here. Can you see that? Can you see that? So if I have a bow tie shape like that, remember bow tie shape only occurs on the circumference. This should be the circumference, circumference, circumference. Not like this. Not like this. Or maybe this one is not it. Can you see this circumference, 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 but this one is not. So this is not. So I can see, okay, C1 is equal to 72. Interesting stuff. Why? Angles, same, angles in the same segment. Okay, I'll write the reasoning. Okay, sharp. Another bow tie, one, I was trying to explain this. Do not say this is a bow tie, this one. This is not. This is not. This is not. This is angle at the center is twice angle at the circumference. Angle at the center is twice angle at the circumference, not the bow tie. Okay. Another thing happen, if you can see, a geometry. I have another cyclic quad here. It touches the circumference. Can you see that it touches the circumference here, there, and there? So, what can I say about this one? If I extend this here, C2, it is equal to angle E1 plus E2. Okay? Why am I saying that? This angle is equal to the interior opposite. Okay? Interior opposite is a interior angle of a cyclic quad. Then another thing I can look out, if I extend it here, D1 and, okay, angle T1 is equal to opposite, okay, A1 plus A2. It's fine, eh? The other ones we'll figure out them when we say question. Calculate giving reasons the size of giving reasons C1. Before I go to the sketch, I check where is C1. Did I find C1 anywhere? Here it is. Here it is. C1. You still remember C1? Angle in a segment. How? How? It means I had something like that. Okay. C1 is equal to 72. Angle in the same segment. I've already written that down. Jot that down. Why? Angles in the same segment. But I'm doing interesting. How is it? Angle O1. Did I find angle O1 anywhere? I look around. Angle O1. It is twice angle D4. Do I know angle of D4? Angle O1, it is twice angle D4. Do I know angle D4? Let me see. Angle O1 here. It is twice angle D4. Okay? But I only know angle, which angle is this? D2 and D3. Okay? I only know those angles. So now the question is, how can I find that one? Okay. Let's look. Did we not find D4 anywhere? By any property, maybe? Let me see again, D4. I'm looking at my information. Any D4. Any D4. Okay, I see D4 here, but it is in a complicated situation. Isn't it a complicated situation? Let me highlight. I'm looking for this one. Maybe I might come up with something. Remember, so that for me to get this one, I should get that one. Okay, the examiner said I should find C1. Why? The examiner should say I should find C1. This one. Okay. Yes. If the examiner said I should find C1, hi, there's no way I can find C1 in this one. The examiner is trying to check you something. Already found this one. Can you see now? Remember, these lines are parallel. Okay. If these lines are parallel like that, and I want this angle to be equal, I can do this. So what do I mean? I can say, okay, these lines are parallel. Do not forget that. And remember, now I used this one, okay? But remember, there are many ways you can write. You can get F like this, F like that, as long as it is F. But if I remove it here, I can also put it here. Can you see that? How nice. Or put it here. As long as it becomes F, like that. So now C1, it is equal to angle O1. Can you see that? Angle O1 is equal to angle C1 is equal to 72 degrees. Why we are saying now corresponding angles such that these two lines OE, it is parallel to CD. Good. D4. Can you see now? Now that I found O1, I can get D4. O1 and D4, relationship between O1 and D4. Can you see here? I had to find D4 first. Okay? And that D4 helped me. Oh, I have to find D4 first before finding. Sorry. I have O1. Okay, so I can find D4. Okay, so remember D4, if this is twice, angle at center is twice, this one will be half. So if this one is 72, so this one will be half of that. Okay, so D4 will be half of that, which will be how much? 36. Why am I saying that? Angle at center, it is twice angle at where? Circumference. Then I move on. I say AED, AED, AED. This angle, the middle angle. Okay, the one with the, normally it is like this. AED, the middle angle. So it is E1 plus E2. Where is E1 plus E2? Here it is. E1 plus E2. Information about E1 plus E2. Here it is. E1 plus E2 is equal to 180 minus 72. AED, it is equal to 180 minus 72, which is 180 degrees. Now I want you to remind you something. Why we said that? We said this is, let this become a what? A cyclic quad. I even added that if we have a quad A, B, D, E. Okay, yes. D1. Any information about D1? If I do not have it, it's fine. Any information about D1? Can I say I see D1 here? D1 is equal to E2. Okay, but the question is, do I have E2? For now, I do not have E2. For D1, I need E2. For now, I do not have E2. Okay, I find another way. I remove this. I find one that has D1. Here it is. D1 is here. Do I know E2? Okay, D4. I think D4 I have. Okay, this one I have. D4 I have. I'm looking for this one. D4 I have. E2 I have. E2 I don't have again. Can you see that? E2 I do not have. D3, do I know I have D3? Do I have D3? No. But I forgot to name something. If this is a straight line, these angles here are equal to what? 180 degrees. That is a straight line, right? Yes. So if I'm looking for D1, do I know D2 plus D4 I have? D4 I have. I need D2 and D3. But can you see here? D2 and D3. 90 degrees. Can you see that? D2 and D3 are equal to 90 degrees. So it means the first thing first that I should find, the examiner is super stingy here. The first thing first I should find here is that angle D1. Remember, this is the information that the examiner cannot see. The examiner does not see this. Does not see this. Only you can see that. Okay? So hence you have to write everything down again. So you just remember that not D1, D2 plus D3. Why? Angle in the semicircle. You can say angle in the semicircle like this, it's fine. So I'm taking this here to help me. But now I remember that what? I'm also taking which information that D1 plus D2 plus D3 plus D4 is equal to 180. D1 plus D2 plus D3 plus D4 is equal to 180. Maybe if there is an easier way, it's fine. You can use it. And now this is the one I see. What is D1? I'm looking for D1. So, or what's the reason here? Supplementary angles. or angles in a straight line. Okay. Then what is D1? So I'm going to say now D1 it is equal to 180 minus all these three angles. Can you see that? So it's going to be 180 minus, this one is 90. 90 plus 86, 126. Yeah, so it's going to be 180 minus these three angles. 90 minus 36. It is equal to 54. Also, 54 degrees. Okay, so this is our answer. Let me see if there is an easier way to get D1 as 54 now. What do I have? I have this one. Okay, I do not have that one. I want to see something. E2 I did not have. Let me see the angle for E2. Oh, can you see now? But the examiner is not fine. What the examiner is doing is not cool. The examiner was supposed to tell you that this line here bisects, okay? So this line here bisects this one into two equal halves. So if the examiner did not give you that, it is very hard to assume in geometry. Sometimes when you assume, you're wrong. Here, angle E1, it is equal to angle E2. This line bisects. OE bisects. Let me see if I missed that one. There's no bisect, it's fine. But remember, we found what this angle, E1 plus E2. E1 plus E2 is 108. So it means this one, it is how much? 54 degrees. This one is how much? 54 degrees. So for that one, you could have said, instead of doing this, you could have said, you could have said E2 is equal to 54. E2 is equal to 54 and come here and say, okay, I can get D1. I can get D1. Why? Because angle E2 is equal to 54 degrees. I want it there twice. Okay? If this rolled one, it is 108. So this one is shared. So you can say now, okay, D1 is still 54 degrees. Why? Normally what the examiner says you should calculate here, you will use it at the bottom part. Why? We say that the reasoning is corresponding angles, such that which two lines, OE and CD, are parallel. Cool. Prove that AF is equal to FD. Where is AF? That AF it is equal to FD. Oh, I'm trying to prove that AF here is equal to FD here. I'm trying to prove that this is F, right? I'm trying to prove that this line and this line are equal. The only time I can prove that it is when if I can prove that if this angle is 90. If I can prove that F3 is 90, I'm done. I can do that easily. Okay, let me try to do that. Do I have O1? Yes, I have O1. O1, remember how much is O1? 72. Another thing I can use maybe, if I can prove this angle, any of these angles is equal to 90, I'm good. Let me see something. Okay, here I can use something. I can also prove this one, okay, is equal to 90. Why? I have E2, I have D4. So I can use exterior angle. If I'm having something like this, can you see it is like that? Then, it is extended like that. Okay, so I know this angle and this angle will be equal to twice that one. Let me do this. If this is x and this is y, this will be x plus y. Okay, so if I can, let me see if they give me 90 now. D4, how much is D4? D4 is 36. How much is E2? E2 is 54. 36 plus 54, 0, 9. This, they give me 90. So, okay, I can get what? F2. First thing first I can do it is to get what? F2. F2, it is equal to what? I want you to see this. D4 plus angle. D4. I want you to see this triangle here I'm talking about. You can also try to prove this one. Remember, if these two lines are equal, it means whenever there is a line here, that line is perpendicular. Remember the theorem here that says if a line drawn from the center, but if that line is perpendicular, these two lines are equal. It bisects the midpoint chord. So, yeah, then when I extend this line here, can you see? This one and this one is equal to twice this one. Okay, this one plus this one is equal to this. So hence I'm saying F2 is equal to D4 plus E2. Okay, then you can also try to prove this is 90, but you need A2. Do you have A2? No, you do not have A2. So it will be just a lot of time to try to find A2. So, but this one I can use F2. So it is equal to, what is D4? D4, it is 36 degrees plus 54 degrees, which it is equal to 90 degrees. Therefore, if this is 90 degrees, like this, can you see? Can you see now? Can you see this is a line from the center? I want you to use a different color. Line from the center to what? If it is perpendicular, 90 degrees perpendicular to the what? To the chord. Can you see that? So you can say therefore, AF, it is equal to FD. Y, line from center line from the center perpendicular to chord. Okay, bisect the chord. Cool. Is OEDC is OEDC a cyclic chord? Give a reason for your answer. OEDC. Let me remove this. O E so OED C, like that. Is it now a cyclic chord? Do not say no because this one does not touch the circumference. For now, no. Let's try to look at the properties that can show that it is a quadrilateral. Let's extend this. If I can prove that C2 it is equal to E2, then it is a quadrilateral, okay? Or if I extend this here, if I can prove that your D1 it is equal to this angle here, then it is okay. Let's see C2. How much is C2? Okay, we do not know C2. Okay, let's try to C2. Let me do this. Let's try to see. Let's try to see if C2 is equal to E2 in any way. Remember E2 we already know is E2 is how much? Oh, 54. Let's see if C2 is equal to 54 now. How can I do that? Can you see down here? If I remove this a little bit, I have a straight line. I have a straight line. So angle C2, it is equal to 180 minus angle C1. How much is angle C1? Remind me. Angle C1 remind me 72 degrees. Okay. How much do we get? 180 minus 72. I get 108 instead. Let me see. OEDC. OEDC. Oh, I get 108 instead. And the E2, it is a half of that. So, no. Okay? Or, without even wasting my time, I could have checked if, let me remove this. I could have checked if C1 plus E2, do they give me 180 now? So this one, it is not a cyclic quad. If I use this one, we will say C2 is not equal to E2. Okay. I'll say C2 is not equal to E2. Okay. Okay. Is C1 equal to E1? No. Angle C1 is equal to 72. And angle E2, it is equal to 54. Angle C1 plus, when I add this, angle C1 plus angle E2, they give me 72 plus 54. They give me 126, which is not equal to 108. So another reason why is not a cyclic quad. Not. Okay. Now I'll come here and reason, is OEDC a cyclic quad? No. The first answer is no. No. Why? I can say E2 plus C1 is not equal to 108. E2 plus C1, angle E2 plus E1 plus C1 is not equal to 108. Okay? Or angle C2 is not equal, so angle C2 is not equal to angle E2. Here you can say opposite angles are not equal. 108. That is what I said. I've already said it mathematically. Okay, so yes. We look at the memo after here so that we see if we are correct with what we are doing. The tangent is to the radius drawn to the point of contact. Okay, if I have a second and I have a radius like that, and I have a tangent passing through. So the tangent is, here's the tangent, to the radius drawn to the point of contact. Point of contact is here. Can you see what is happening there? 90 degrees. So it is perpendicular. Do not do that. Just write perpendicular. Like that. Now use the diagram below. A, B, C are, okay? A, B, and C are on the circle with center O. Or, okay, PA is a tangent. PA is a tangent. It's very important that they tell you it is a tangent. Use a diagram to prove that BAP, this angle, it is equal to this angle required to prove. Now, If it was of me, I wouldn't do this question. Why? I would say go to the videos that I've recorded under proofs. Under proofs. Okay, there is a video that is go to my channel and now go to your play list and check for Euclidean geometry grade 10 and 11. Okay, I think it is the first playlist. But let's do that. What I'll do, I'll construct, sorry, my English is running away. Construct a diameter from A. People get confused whether I get it to A, then where. Then someone when comes here, gets stuck whether I go there or I go there. There is easy. Go to the angle that you're trying to prove, which is C. Okay? Just name this 1, 2, 1, 2. You are naming this on your answer sheet, not on your question paper. The examiner does not see your question paper. When you prove, you will be given a clean sheet of this part, the way to prove thereof. Let's prove. Remember, we just proved that a diameter, okay. Okay, if this is a diameter, but what is the property about diameter? Remember diameter and here. The angle subtended by that diameter is equal to 90. Sorry, 90 degrees. So this angle is equal to 90 degrees. So what do I mean by that? So it means now angle E1, sorry, not E1, sorry. Angle C1 plus angle C2 is equal to 90 degrees. Why? Angle in semicircle. Okay. Another thing happened. Remember, we just said if I have a second and a radius, a tangent and a radius, it gives me how much? 90 degrees. So similarly here, remember if this is a diameter, so if this is a diameter from here to there, it means from the center to here, it is a what? A radius. And then I have a what? A tangent. Okay. So remember this gives me 90 degrees. Do you remember that? We just reminded you in the exam. So you'll say angle A1, angle A1 plus angle A2 equal to 90 degrees. Tan perpendicular to radius, tangent perpendicular to radius, right? But I want you to see something. Can you see here what I have? A bow tie, okay? Okay, a bow tie. You'll say, okay, can you see that both of, before I come here, can you see that if these are equal to 90 degrees, it means these two are equal to one another because why? They are both equal to 90 degrees. So it means I can say, therefore, angle C1 plus angle C2, it is equal to angle A1 plus angle A2, right? But, or I can do my but like this. But, this is therefore. But let me write it but like this. Yo, I've been repeating but 4 times to 20 million times. But C2 is equal to A1. Why? Angles in the same segment. If this and this are equal, what does this tell me? It tells me that this color also, this one, should be equal to that one. Why? Someone might say, Alushano. If, okay, let me do this. C1 plus C2 is equal to A1 plus A2. If these are equal, if this is fixed, and this is 60 plus A2 plus C1. Can you see now? This one I can cancel because they are the same. If it means C1 is equal to angle A2. Can you see that? Therefore, angle C1 is equal to angle A2. Let's see if C1 and A2 are the angles that they're looking for now. C1, yes. C1 is angle C. And A2, yes, A2 is BAP. Can you see that? We have proven that. So yeah, you are done. You can leave it like that, or you can just be nice and say, therefore, you can be nice and therefore angle C. Can you see C1 is angle C? That one is equal to angle B angle AP. You do not need to. You do not need to because you already indicated here. The examiner will look. The examiner cannot give you work, and when you cannot give the examiner work here. Okay. Interesting question. I wonder how it is. Oh, by the way, I do not look at the memo until I am done doing the question. Okay, yeah. Prove that RU is equal to RQ. We'll come back to that. In the figure below, PQRS are the points on the circle. PQ is produced such that RE, TP is a tangent to a circle. I want this one. This one is not important. This one is important. This one is also important. This one is also important. Can you see? I'm told that this is a tangent. TP, tangent, good. That is a tangent, good. Then I'm also told that PR is equal to SP. Okay, they have shown me that. Can you see? I'll highlight that. Angle U1, angle U, sorry. This angle is equal to angle P1. Where is P1? We do not know why. But this is the information we are given. Now we are trying to prove that RU is equal to RQ. Or RU is equal to RQ sharp. So basically what we are trying to say, if it's like this, if you are trying to prove this side is equal to this side, just when I give you hint, prove that angle U it is equal to angle Q1. If these two angles are equal, like this, then these sides are equal. Remember the property that says opposite angles equal sides, opposite side equal angles. Yes. This is our aim. Yeah, our aim. Let's look at our aim. Now let's use the property that they give us. I have P1, okay, and I can use P1. Remember, this is a tangent. A tangent and a chord. An angle between a tangent and a chord, P1. It is equal to the angle subtended by the same chord at the circumference. Can you see that? Can you see that? So it is equal to this one. Okay? This is me trying to see if I am going in the right direction. Okay? I'm told that what? Okay, I'll say angle R1. Angle R1 is equal to angle P1. Why? Tan chord theorem. Then I'm going to highlight this with black because I've proven it is equal to that one. Okay? But remember, if these two sides are equal, this one and that one are equal. So it means this angle and this angle are equal. It means this angle and this angle are equal. Okay? So I can now say I shade this one. Why? I say that one angle S. Angle S, it is equal to angle R1. Okay, angle S is equal to angle R1. Why? Why? Angles opposite equal sides. Cool. Remember, I'm trying to come here. I'm trying to get Q1. Okay. Any relationship between I can see something in the examiner will not always tell you, but what will the examiner tell you is that we have SRPQ222 things like that. Like we have PQRS. Can you see? PQRS are points on the sometimes they like to do that. Just look out for a quadrilateral if they do that. Remember, if this is a quadrilateral like this, what property can I use? I can say I extend this line like this. Remember, if I extend this line, this angle will equal to the opposite interior angle. What do I mean? I mean angle Q1 will equal to angle S. Okay? Angle S. Will equal to angle S. Okay? Angle Q1 will equal to angle S. Angle S, angle S, angle S. Yeah. Why? Oh, I want the reason. Why exterior angle of a cyclic quadrilateral. Cyclic quad. Good. Can you see now? If this is equal to that, if this is equal to that, it means this one will gain a black shade. Ha! Finally got what? Try to. Here is my try to prove that angle E is equal to angle Q1. Good. Can you see that? Now it means now is this angle S. Now check. If angle Q1 is equal to angle S and angle S was equal to L1, can you see that this is a match here? This is a match there. This is a match there. Okay. And remember the common one that we started with, that we're given that angle U, this one. And this one. We were given those. Okay. So, and look at what R1 is equal to. R1, it is equal to, okay. When you are here, it's fine. What I like to do so that I do not get confused, I say let angle U equal to X. Then I tell my examiner, okay, this is X, this is X. And I proved this is X, and I proved this is X, and I proved this is X. So if you have done this on your answer sheet, the examiner will see. So say this will equal to X, will equal to X, will equal to X. Okay. Therefore, just conclude. Therefore, angle U it is equal to angle Q1. They are all equal to X. Okay, they are both equal to X. But how does that help us? It helps us because RU and RQ, okay, will be equal. Therefore, RU it is equal to RQ. We need a reason for that. The reason is that converse. Remember when you are trying to prove something, you say converse what? Opposite sides. These are opposite sides. Equal what? Angles. Cool. Cool. So what you had to realize is that, okay, if you want to prove this one is equal to this one, what you can do yourself a favor, where now prove that U is equal to Q. If you have proven that these are equal, then these two are equal. This is what the examiner is trying to do. The examiner is trying to say to you, also prove that angle U is equal to angle Q1, like that. So yes, that's the end of our question paper. I hope you enjoyed. So now, if you liked the video and if you're struggling with geometry, please look out for my playlist under my channel. I explained geometry very well. Also proofs. Remember, in June you'll have only one proof. There will appear one proof that you'll regret not watching. So now let's look at the memo. I'm not gonna go through with the memo with you. I'll just pause and you'll pause for that moment and check our answers are correct or not. Okay. And check for alternative method maybe that you might have used when we answer this question paper. Can you see? There are methods there. The reasons. Okay. Here also. Let me remove this. And here. Here. Oh, sometimes the memo has an error. Okay, I'll show you where there is an error. I'll show you. Okay, continue like that. Here. Here. Here, remember, they are substituting a point. Which point? -4. And we are talking about BC. Remember 2.5 was say find the gradient of BC. But substitute the point of A. Ne? The point of A has a coordinate. Let's go back. The coordinate of A has a point -2 and 4. But check out what did they substitute for X. Remember the point of A, it is -2 and 4. The Y, remember it is the Y1, it is a formula 4. Here it is. But can you see now, instead of saying +2 here, which is -2, which will form +2, can you see they said +1? So that is an error you should look out for when looking at the memo. Okay, so this one is incorrect. So this was supposed to be +2, and this will have given us -1, -1 here, +4, which is in case +3. Okay, look out for that. Here, another one. Here, you can just confirm that on a calculator if you got the same answer or not. If not, maybe I'm the one, I did a mistake, I forgot what, it's fine. Okay. Here, can you see that? The triangle I was talking about. You can just pause and screenshot. Okay. 3.4, 3.5, like that. Maybe there are other methods they used. Or another thing, when you prove left-hand side, right? Then when you're done, when you have found the right-hand side, this is equal to, just say this is equal to right-hand side. Remember, when we started to prove, we said left-hand side is equal to, okay? Remember the thing that I told you? You put this handle, then you do what? You find the reference angle. Instead of saying theta plus 10 is equal to that one. Okay, after getting your reference angle, I did not get this in numbers. Okay, I don't think I got that angle. But yeah, even if I did not get that angle, the method will be the same. Okay. Yeah, I think I did 5 divided by 4 now. Let me see. 5 divided by 4. Oh yeah. I think I made a mistake here. Instead of 4 divided by 5, I did 5 divided by 4. Okay. Let me go back there and show you. I made a mistake where it's very easy to make mistakes such like that. Can you see? Yeah, can you see here? Uh Instead of 4 divided by 5, I said 5 divided by 4. Can you see that? So this fix to 4 divided by 5. But hey, the method is still the same, okay? The method is still the same. See, when I said I do not look at the memo, I can now identify my mistakes because I remember very well what I did. Okay? Then can you see still the same 180 x is an element of integers? Can you see integers like that? Yeah, I don't know how to do that. But can you see the quadrant is still the same, first quadrant and third quadrant? Can you see that shape of I got the exact same shape. Okay. Can you see? That's 6 marks. The period was 180. I got that one. We got. Okay. You can just look at this. Okay. Bisect the chord. Then can you see? We used the angles. Yes. We got those. N1 and N2. Can you see now the memo is doing mistakes? This was not N1. Here it was E1 plus E2. So do not become confused. Here it was E1 plus E2. Sometimes what they do, they just do copy and paste the examiners. So yeah, don't be confused sometimes. Then can you see here why and the marks were 2 marks there. Can you see why I said we should use this one instead of using the one that says it bisects? No, but the examiner there said it was 2 marks. I wanted to show you something. One thing I do not forget what I did. Here it was 2 marks. Can you see that? Can you see? Here. Where's that? We were trying to find what? E2, C2, D1, D1. Here. Can you see? It was 2 marks here. So the examiner changed a mark allocation. Hence, now what you have to be careful of, the examiners, they become lazy sometimes to set a question paper. It's so difficult to set a question paper. It's difficult. And it is time consuming. Okay? So we're here. Where were we? We're here. So yes, that one. Get that one. Then yeah, prove that is F90. Then they are equal, perpendicular from the center to chord. No. You still remember? They are not. Why E2 plus C1 is not equal to 108. Or opposite angles are not supplementary. Okay, or are not equal to 180 degrees. You see that? Last one, you said, no, this one cannot be bisect. The answer bisect was the answer for here. This was the bisect. Here, it is perpendicular. Okay? Perpendicular. So, it is something like, remember, I'll repeat, if this is a tangent, okay, maybe a radius here. Let's say a chord, a radius there. Sorry, a tangent there and a radius. Can you see? Can you see? Okay. I can accept bisect. Bisect, it is also correct because this will be called 90 degrees and this will be like that. But perpendicular to the tangent is also correct answer. Remember, the reasoning is perpendicular to the okay. Remember, I said when you construct a diameter, then you join it to the one you're trying to prove. Can you see? Remember, I said name there, name. But as you name on your answer sheet, then can you see? For construction, it is 1 mark. If you do not construct, you get 0 out of 6. Yeah, I'm just telling you. C1 and this one, Y angle in the semicircle. Okay. Therefore, C2 is equal to, you can say C2 90 minus angle C1 here. The examiner is short of something. Angle C2 is equal to 90 minus C1, okay? Then here, angle A1 plus angle A2 here, tan perpendicular to radius. Then you can say angle A1 in terms of angle A1 is equal to take this one to the other side. It becomes A1 is equal to angle A2, okay? But what? But C2 is equal to A2. C2, it is equal to A2, okay? If C2 is equal to A2, then what? Okay, here, I don't know how the examiner proved that. C2 is equal to A2. This one is equal to that one. So it means here you can say angle A2 it is equal to, instead of this, angle A2 is equal to 90 minus angle A1. Okay? Then if this one and that one are equal, C2 and A2, if C2 and A, no, not C2 and A2, C2, C1 and A2. Okay, this one is correct. Just that here it is C1 and A2. Okay, so if these two are equal, it means now these two will also be equal, meaning 90 degrees minus C1 will be equal to 90 degrees minus A2. But can you see this is 90, this is 90. Then this is negative C1 is equal to negative A2. Divided by negative C1 is equal to, can you see that? So yeah, interesting stuff. And here I proved, remember I said let this one become X, this one become X. Then we proved that angle S is equal to tan chord rho. Then we said this one and this one, okay? Or we did not even need to go there. If you are here, you can just come here and say this is X. Why? Let me remove this. Let me say this one only, né? X. Then this one is X. Then what? Remember Q1 will be X, Y, exterior angle of a cyclic quad. Okay? Yes. That one we used tan chord theorem. This one we used tan chord. Then, but this one, remember angle U is equal to P1, so this is also equal to X. Therefore, this one was given. Therefore, U1 is equal to angle Q1. Therefore, angles opposite sides are equal. So, yeah. So that was all. So thank you very much, folks, for watching this video with me. I hope you understood. And yeah, hope you write mathematics paper 2 very well. Yeah. Thank you very much. And I repeat again, if you're still struggling with geometry, go watch my videos, okay? Yes. Thank you.